Hello and welcome to the boat shed. In today's video we're going to be trying a new method to dry out the bulwarks that we've been working on, and let's get things started right away by finishing up that repair up at the bow. If you're new here, my name is John and this boat is Antidote. Now I am not a pro boat builder, but I'm an engineer and a sailor with the dream of fixing up this old boat to go sailing around the world someday. Now we've got a lot of work to do first. Now last time that we were here, we were putting some new fiberglass layers up at the bow here, where we had removed an old seacock and ground down a big 12-to-1 bevel. So let's take a look at how things are going. Now, this is a multi-step procedure, and this is actually the third lamination layer that we've done on this repair, and we have at least one more to do. We have the last center section to go. We've been working our way from the outside to the inside, building up that almost 3/4 of an inch, or it's about 18 millimeters, 18.5 millimeters for the rest of the world out there. We have been using vacuum for these repairs, and it's not a necessary step, but it's something that I enjoy doing because it really compacts those fibers down, gives you a really nice finish, and I think it's worth the extra time. Now you have to do multiple layers, of course, because the epoxy is exothermic. It creates a lot of heat, and if you get it too thick, it can actually get too hot and damage lamination. Maybe not an issue when you're working at around the lower minimums of the epoxy working window, which is 40 degrees. So I probably could put thicker layers on. I'm still learning and experimenting on where those boundaries are. So we've done 4 layers and then 2 of 5 each, and those have all worked just fine. When I've applied these sort of later in the day, or when I only want to do one a day, I'll usually leave the temperature lower if I can to around that 40-degree mark. That way the reaction takes a little bit longer, and as it cooks overnight, then it's ready in the morning for the next layer, but it's not fully cured up. So it still has a bit of open tackiness, just ever so slightly. You can get a little bit of a chemical bond. And then if I'm gonna be doing multiples in the day, I have used heat lamps and other heating from inside the boat to try to encourage the laminate to cure up so I can do a second coat in a day. And so I was able to do 2 of these yesterday. Until recently, the vacuum was on full, and you can see it's still actually holding on relatively well, which I think is interesting because I was concerned about this tape bonding to the hull because the paint is a little bit rough, but surprisingly this is holding up really nicely. So this vacuum is actually rather tight, and I've been able to use this 3 times. So I've been just peeling the bag back carefully, applying my next layer, and then putting all the bag back up. So it has cut down on a bit of time and also the materials. So that's great. Let's get going now, taking this apart, see how it all looks, prep that last layer to put on, and see if we can get this finished up. I do find that a little gentle tug usually releases the tape nicely, and maybe the cold weather is helping too. Did I mention this is the 3rd time I've been able to use this bag? So just very gently peeling it off the center now. So it's not already obvious, one of the most rewarding parts about using the vacuum is watching the resin push through the release fabric into the breather. This is part of the process that as the fibers compact, some of the extra resin, because I usually mix it up at 50-50, that's resin to glass ratio, and so some of that ends up in the breather and it gives you a more ideal ratio. Now, we're not building a race boat here, but anyway, it's fun to experiment with this stuff. And of course, removing the peel ply, my favorite part of every day. With the peel ply removed, you can see everything is nicely compacted. All the edges are just pushed into each other. So you have a fairly smooth transition here. It is a little bit lumpy. Now, hopefully it's not too far proud of the original curve and we can do minimal grinding to get this back. This is my first big repair, so we're gonna have to just see how it goes. Sounds good. Now, since we are operating on the margins of the temperatures again, with it being 40 degrees inside the shed, the substrate right now is about 53, which is fine. And then inside the shop, we have the glass and the resin. It's been sitting at around 70. So it's gonna be nice and thin. It'll penetrate the glass well and wet it out. Then we can stick it on here. And since it's gonna be 40 or above, the resin will cure just fine, but I will probably put some heat on inside the boat and then maybe a lamp on the outside as well, just to promote a good cure, since we do have the majority of the glass on now and I wanna give it a good chance for all those bonds to form. Let's get going. let's say hi to a couple of the new Patreon crew members that really help keep this channel humming along. If you're interested in some behind the scenes updates and ad-free videos, then you can check out the Patreon link in the description down below. The folks whose names are appearing on the screen now go the extra mile to keep this channel moving, and I couldn't do it without you. Thanks all so much. Back to the video. Those next 5 layers are now fully vacuumed down, and we're gonna let those cure up for a while. So you see we've got a little bit of resin squeezed through, and I've brought out the heat lamp here, and we also have a heat source inside the boat, so we're heating this whole thing from both sides, just to try to bring the temperature up to like 70, 80 in that area, not too high. And we're gonna leave this now to cook for a while and get some good bonds linking up so that glass gets nice and solidified. We're using 10 inches of mercury vacuum to pull this down, and we did have a little bit of a mishap with a higher vacuum. I'll tell you about that now inside. While we're on our way there, is anyone thinking about going to the Vancouver Boat Show this year? If you are, let me save you $5 off your tickets. We'll put a link down below. You can use the code LFS at checkout for that. And we will try to be there on the Friday, Saturday, and Sunday in some capacity. So we would love to see you there. Come on by, say hello, check out the show, and maybe we'll get a Patreon meetup together if we can get some people round up. So love to see you there. During the initial excitement of the first vacuum bag pull down, I noticed that we had a little bit more pressure than I was planning on using in the vacuum system. So we were running at close to 20 inches of mercury, and I was really aiming for 10. And I think I just forgot to adjust it before I started up. I'm gonna change my startup procedures from now on. My decision was to let it go and to finish hardening up at that setting rather than to back it off after I'd noticed it, since I'd already pulled some resin out of the glass, and I didn't want to start creating voids or air pockets by letting the pressure off. Typically, when you're starting out with a wet layup, you'll get about a 1-to-1 glass to resin ratio, or 50-50. Now, 60-40 glass to resin is actually your kind of ideal sweet spot as far as strength to weight ratio is concerned. So you can go as high as 60% glass to 40% resin and have a really strong composite. So as we were pulling the part down with the vacuum, we noticed that the peel ply got quite saturated as well as the breather. So the question is, where did we end up on that 60-40 area? You can see here there's lots of saturation in the peel ply and again in the breather fabric. So if we figure that the only place the resin can go is into these two materials, we can weigh them out here, and this is 11 ounces with the addition of the resin that got pulled through. And I have here a couple of pieces that I cut out of the same material in the correct sizes, the same sizes. And if we weigh this up, we get about 3 ounces. So 8 ounces of resin has made its way from the fiberglass composite into the breather material and the peel ply. It's been removed. Now I know I started with 20 ounces of fiberglass because I wrote it down on the piece of peel ply here, and I added 2 more ounces to the substrate before I put any of the glass on with some 4-3 thickened epoxy to act as a bit of a glue. And so when I crunch all the numbers, at the end of the day, we end up with a 59% to 41% fiberglass to resin ratio. So we're inside that window. It also looked good to me when I was checking it out. So that is my decision to leave it on. I think it's a really nicely compacted and glued on fiberglass. You may have noticed that that math was running a little bit fast and loose there. So I typically use 1 fluid ounce of resin for each weight ounce of glass. And now, why in this country we use a system of weights and measures that uses the same word for a weight as a volume measurement is well beyond me.
We will use gallons, pints, and quarts, God willing.
Okay. How many liters are in a gallon, sir?
Nobody knows.
Espousing the benefits of the metric system, although I am originally from Canada, is not what this video is about, so we'll carry on. The density of the resin that I'm using is 1.175 ounces per fluid ounce. There it is again. So we actually start off a little bit resin rich at 44 to 56 glass to resin ratio, and then this usually ends up around 50-50, which is what you typically get in a wet hand layup. Now in our actual application here, accounting for that density of the resin, this puts us at 53 to 47 glass to resin ratio. So we're well within that window that we want to be, so everything looks good, we carry on. Another thing I failed to mention in the previous video was that before I put anything on that old substrate, because a lot of you have commented, this is an old boat, it likely has a wet hull below the waterline, because you don't want to be putting anything on fiberglass, resin, unless you have a dry substrate. After the grinding, checking with my moisture meter, I got 0 readings, dead readings, essentially 0, 0, 0. Possibly aligning with some rumors that I've heard that these boats, the later models, were built with vinyl ester resin, which has less of a tendency to absorb water like polyester does. So that would be great. Still not 100% positive. I'd love to get that tested. Not sure how that works. If you do that kind of testing, let me know. But with those results coming up in my favor, I decided to press on with the laminate repair. So now, speaking of drying things out, we need to get working on drying out that old Bulwark. So take a look at this. The next step with the Bulwark project is to get it cleaned up and dried out in preparation for new material. Now, in the last video, I did give you a little white lie and I told you that the Bulwark is practically finished on the starboard side. Well, I had a little bit of catching up to do on the area that was forward of the first chain plate, which is where I first discovered that there was 2 portions of plywood in there. So now I can report that the starboard side is completely excavated. I've been able to take care of all of that. There's no more wood in there, thankfully. For drying it out, we want to try and raise the temperature in there, lower the humidity. We are getting into a colder part of the season here, so I need to do some localized heating, and I have a couple of ideas. So what I want to do is create a little system to move some air throughout that Bulwark and raise the temperature if possible. Raising the temperature brings the relative humidity down, gives that moisture somewhere to go, and having the air moving around in there is going to hopefully dry it out quicker than just leaving it to sit still. So one thing that's going to get that started here is this fan. So we have this fan that I picked up, and this was about 30 bucks, which for me was a great deal. I like this style of fan, these vane fans, because they work really well on vacuum, so they can pull air through a system, and they also are fine pushing it. Some of the coaxial fans that go right into like a 4-inch duct don't really do a good job of drawing air through very little volume. So we'll use this to pull air through the Bulwark once we get it sealed up. I'm thinking I'm going to try and adapt this standard. This is a North American standard 4x10 floor register box. I don't know what they use in the rest of the world, and a little elbow here that's adjustable. I'm going to try to fit this over the Bulwark. We'll have to cut it, adapt it a bit, tape it in place with some gaff tape. And then this is going to kind of be our suction side. And then on the other side, we'll let the air in. And I'll probably use sporadically something like this. This is just a regular old hairdryer. This is the Conair Yellowbird. This came to me by way of Adam Savage's channel. He's the old Mythbuster guy. Well, he's not old.
I reject your reality and substitute my own.
And he really loves this thing for throwing heat on stuff. It has a few different settings, and it's sort of more of their industrial grade. This is not a 100% duty cycle industrial rated fan though, so I'm gonna need to keep an eye on this and monitor it. But it doesn't throw out too much heat, but just enough. And I don't want this to be responsible to push the air through the system. That's why I have the fan that's designed for moving air. This is just gonna add a little bit of heat. It'll raise the temperature though of the air moving through. That's the plan. Let's head up now and see if we can get any of this to work.
Before we go ahead and add a whole bunch of heat and air to the bulwarks, I think it's a good idea to get them cleaned out, all that dust out of there first.
With all the plywood now removed from the Bulwark, there's just a little bit of dust along the bottom that I'd like to clean up. And we've been using this tool here that our friend in Texas made us. And this is great for scraping along the bottom and pulling up some of that material, but it doesn't quite get all of that dust out, and I don't have a vacuum attachment to reach the bottom. But a friend of mine in Vancouver has a 3D printer. And so I sketched up this part here, and he was able to print this for me in 2 pieces. And so we have on the business end a nice thin little port for sucking up the dust, and then this meets up nicely with my vacuum hose here. So we'll see how this works, how long it lasts, but pretty cool little tool. So this is going to get all the way down to the bottom, pull that dust up. Let's see how it works. Awesome. Well, this little guy works wonders. That's great. It's all about having the right tools. So with this cleaned up now, we're going to see if we can fashion up a way to get that air moving through here. All right, so we're going to try to get this piece down on here somewhere. This will be the outlet, and then we'll bring in an intake over here. We'll just try this first 4 or 5 foot section, get it running for a few days, and see if we have any drops in the readings, see if we want to invest more time into this plan. But I'm trying to right now visualize how I'm going to mark this and cut this to fit over this bulwark. I also want to make it adaptable as it goes down the boat, so we're gonna just kind of guess and check here, but we'll get something figured out. This has a pretty decent fit now. I mean, it's not going to be perfect. I just want to get as much of this sealed up as I can. This might do the trick. We'll have to seal up this end, of course, and then we'll tape over the top here to try to bring the air through the bulwark, but it might work. So we have the back half of the system now set up. So the outlet pipe is on, it's all taped on and secured. I used a little bit of my vacuum putty sealing tape to just sort of gum up and seal up some of the cracks and openings that were a little difficult to get with the tape. We're using the 4-inch semi-rigid aluminum ducting here, and that doesn't collapse under the very small vacuum that this fan will create. I've taken some rubber pipe insulation and I've cut off the sticky bits on the sides just so there's not adhesive gonna gum up anything in there. And I was using this to cover the top of the 2 channels so that I could make sure that the air goes through the channels and not just over the top in that opening. So hopefully now we're forcing all the air to go through the bulwark. And I've used gaff tape to seal the top. I like the gaff tape because it doesn't leave any residue. It's pretty good. I've covered the holes for the hawse cleats and the stanchions. I think we're all ready to go. So we'll run it and see. It's firing up. It's moving some air. And I don't know if you'll be able to hear the airflow at the front, but we'll see. Maybe we can hear the airflow. With the outlet section working now, we gotta take care of the inlet, and I used this 4-inch piece of pipe, hacked it up here, and I used some tape on the edges because that stuff is so sharp when you cut it. But this actually fits reasonably well over the bow, captures all that sort of inlet side, and then I cut 2 slots in there so that I could put a band clamp inside there. And then the hope is that the hairdryer will go in, and then I can clamp that down. And then you see there's still a lot of open airspace there, so the air can get pushed in, and this is just going to add heat. It's not going to be forcing. This fan isn't doing the work of moving the air, it's just adding the heat. That's the idea. Okay, it looks like everything is all set up, so now it's the moment of truth. We have the intake pipe on, the hairdryer is ready to go. We put a thermocouple on the back here so we can monitor the temperature, see it rise, and hopefully we'll get a lot of air moving through here, and then over the next couple of days, the moisture levels may hopefully drop down. So let's see, let's give it a try.
Let's leave things now to run for a little while. It's been about 40 minutes and the temperature stabilized in the 80s, so approximately 40-degree temperature rise, not too bad. And I will probably install a duty cycle timer for that dryer because it's not technically rated for that, or maybe I'll just buck up and buy 100% duty cycle rated heat source. Anyway, so far it's working the way I had hoped, and if this works well, we'll extend it further down the boat. Now, if you're enjoying the video so far and you'd like to show this channel a little bit of love, the best thing you can do for me is hit that like button down there. Well, I guess the best thing you could do is take out a full page ad in Sailing Magazine or tell all of your friends about it, but this is just so much easier. So right down there, appreciate it very much. And that brings us now to this fiberglass patch that we were working on in the last video, and have put these last layers on here, and they are now all hardened up, so we should be able to take this apart. Now, this whole repair generated quite a bit of controversy in the last video, so we'll get to more of that in a little bit, but for now, let's just open it up, see how it looks. Well, initial impressions are positive. It feels pretty good. You know, it's not totally smooth, obviously. That's not what I was expecting. There is maybe like one little low spot here I'm feeling, which is interesting to me. So maybe I would fill in a little bit more glass there. I think we'll need to take the mastic tape off to be able to put a batten across this to sort of see how it landed. Generally good. It looks really solid. It sounds great. So the last video, we generated quite a lot of comments and buzz around this patch idea. And there was two main issues that people seem to have with this approach. One was that it's so large, why so big? And the other one was that, John, you've clearly done this backwards, putting the large patch on first and ending with the smallest patch. Now, this is a controversial subject, I understand, and so I'm fine with that. These are decisions that I made while consulting with some fiberglass experts. So what I did, is it right for everyone? Probably not. Did it work for me? I think so. In this case, we're going to be really good, but I can understand that there's some concern about it. So the reason that it ended up so big is because we honored that 12:1 bevel based on the thickness of the hull. So that dictated the full size of the patch. Now, working from both sides, inside and outside, would have essentially cut the diameter in half. That would have been a good approach. The reason I didn't want to work on the inside heavily was because it's basically below my foot level while I'm sitting in there, and then working over the top, it just wasn't a very convenient thing to do. And now that's never really a good reason to avoid something, is because of convenience. I think honestly, if I was starting again, I would probably make more effort to grind at least a third to a quarter, 50% ideal from the inside with a nice bevel, so that I could have done this patch from both sides, reducing the area. And really the big reason for that would have been to avoid a lot of grinding and sanding here that I'm gonna have to do to fare this back out. But you know, structurally, after talking with some experts, well-prepared fiberglass that's dry, using epoxy, good quality mat like this 1708, there should be nothing here to worry about. This is probably stronger than the rest of the boat around it, and well bonded to the existing structure because we used a nice solid epoxy like the Hawk epoxy. So we're going to be really good there. Now, working from large patch to small patch versus small to large, you know, some people are very confident that this was done backwards, and that's fine. Even people that admittedly have zero experience with boat building, and I have just slightly more than that. So the reason that I went with a large patch first is, again, because there's a series of experts that recommend it that way. Not everybody, but most do, especially for marine applications. And there's a couple of schools of thought why this is a better approach, and someone in the comments nailed both really. And the one is that with the large patch going on first, you have the largest possible area of a secondary bond. Of course, you'd have to make sure that first laminate goes down really well, and that's why we used the thickened epoxy on that first coat. We put some 403 in there to make sort of a glue, and then it was all vacuumed down, super clean, super dry, and so that is gonna give me a really good secondary bond. My experience has been, and I have done both ways in the past, is that when you do the smaller ones first, every successive layer then can have an air pocket around the rim. Not always. If you're very careful with rolling out and using thicker epoxy especially, it would probably work fine. But generally, this is the way it's recommended. The other thing that can often happen is that when you have all of your patches down, if I've come out a little bit high here and we're grinding things away, I'll be grinding off these small little patches that don't really have a lot of structural significance. If I'd have put my large patch down and it ended up proud and I'm grinding that off, now you've got a big structural donut instead of a solid piece of fiberglass. So This is a way that you make sure that you keep your structural integrity is higher overall in this case. And the people that say, well, you know, if one half of this just falls off or if the whole thing just falls off, then you've got nothing. That's absolutely the case if you believe that this is all just going to fall off, and I don't really think that's the case. If I was trying to use polyester resin or even vinyl ester resin, I can see the concern about not getting a good bond, but epoxy sticks so well to everything. It's not just a laminating resin, it's also rated as a glue, as an adhesive. So it really is the best of both worlds for this kind of repair. And so I have very high confidence in the epoxy and the fiberglass bonding on that first very large layer. And so I think this whole repair is going to have a very, very long service life. I'll probably never need to think about it ever again. So there's my honest take on how I think this came out. Now there's probably still differing opinions out there, which is fine. I'm pretty forthcoming with not being a professional boat builder, but I do try to consult with experts before I make my decisions, and I'm not always going to get it right. Sometimes I'll make a mistake. Sometimes I will go down a path that maybe is not the best solution, certainly not the fastest. But this is kind of an exploratory mission that we're all going on together. And so I welcome the comments that say I would have done it differently, or John, you're wrong, or you're crazy. It's all good. It's all feedback, and I appreciate it all. But I did want to loop back and tell you why I did it this way. So now I think we should take some of this sticky tape off, and maybe we can try and lay a batten across here and see how it looks. If I do want to add more glass in here to fill in a little low spot, I'm probably not going to worry about using, gosh, this is really stuck on there. I won't worry about using a vacuum for that, any successive layers. So we'll take this tape off now. These colder temperatures, the vacuum tape is actually kind of brittle and it's not coming off super easily. So we're going to add a little bit of heat, see if we can help things along. Wow, that was much harder than I expected. I have this cheap batten. It's just a piece of door skin, really. This is not an approved method, perhaps, but I used this when I was grinding out the opening to sort of see that I had a good straight taper. I was also using the rings of the old fiberglass as sort of a guide. And it's going to be hard to appreciate in the 2D world that you're watching this from, but the curve here is really complex, and it isn't just even just compound in two directions. It actually changes shape completely from the bottom as it goes up, and I'll try and show you that as best I can. But with the batten here applied, I'm actually looking at pretty good results. I think there's a few spots where I would have liked to maybe have the patch shaped slightly different than perfect circle to give me a better fill, but overall really good. And I might still add a couple small pieces of glass perhaps to fill in some of these lower spots if I think that they'll still be completely under when I go to sand all this. So, but overall I'm pretty happy with this. I think it came out pretty good. I wouldn't say it's fair, but it's close. And yeah, we'll have a lot of grinding and sanding and fairing to do here because I decided to make the patch so much bigger than I perhaps could have gotten away with, certainly could have gotten away with had I have gone from both sides. So I think that's all we're going to need to do today on that repair. It looks pretty good, but before I get priming it, fairing it, painting it, and all that good stuff, there is one more thing I want to do over here, and that'll be in a future video. So I might just cover it up for now. But if you're new to the channel and you'd like to get caught up from the beginning, there's a playlist for you here. And if you want to subscribe and aren't yet, that would be awesome. That helps with the channel a lot, and the button is right there. See y'all next time. Can you see that? It's cold in here. So that's a 44-degree temperature rise. Is that right? Yeah. That was right. Oh well. Take it again. From the top.